Now, after discussing OTA in a generic at a generic level, now we will see about OTA in automotive industry. All right. Now, within automotive industry, how this OTA is used. Now, what is the introduction to automotive OTA? Over the air updates in automotive industry refers to wireless delivery of software, firmware and configuration updates to the vehicles. This technology allows automakers to remotely improve vehicle functionality, fix bugs, enhance security, and even add new features without requiring a visit to the dealership. Alright, so this sentence is very important, without requiring a visit to the dealership. Now, why automotive OTA is a game changer? Many OEMs or automakers are seeing this automotive OTA or automotive over the air as a game changer because it reduces the recall costs. Tesla saves millions by fixing issues via OTA. It also enables continuous improvement, new autopilot features, battery optimizations, software updates, new version of the software. All this continuous improvement can happen remotely. And it also enhances cyber security. Of course, it also enhances cyber security risk also, but it enhances cyber security also. It is like a dual-edged knife because of the rapid patching of the vulnerabilities. So whenever there is vulnerability, it immediately patches. Now it also improves customer satisfaction. No need for inconvenient service visits. This is the main problem this OTA is solving. I repeat, no need to no need for inconvenient service visits. This is the problem which OTA is solving. Now let's see the various types of the OTA updates. Automotive OTA updates can be classified based on electronic control unit they target. So it is categorized based on the type of the electronic control unit. Now when it comes to, in this table we will see the type, the description and examples. Infotainment system updates means updates for touchscreen, navigation and media systems. Alright, and the example is Tesla's user interface upgrades or BMW iDrive updates. These are all the various examples and which are actually implemented in various OEMs, whether Tesla or BMW. This actually is using on. This looks like a science fiction, but trust me, this is already in implementation. Next is telematics and connectivity updates. It improves modem firmware, 5G and V2X communication. The 5G modem patches and eSIM provisioning. These are the examples. Now, when it comes to advanced driver assistance system, it enhances autopilot, lane keeping and collision avoidance. And the example is Tesla Autopilot, Ford Blue Cruise improvements. Ford Blue Cruise is a very modern ADAS system. Okay, and powertrain and battery management updates. This optimizes engine performance, EV battery efficiently. Okay, and this is already the example is Tesla battery range boost and charging speed tweaks. Now coming to body control module, it adjusts lighting, climate control, door locks. Okay, and the example is remote HVAC improvements, key fob security patches. And coming to the safety critical updates, the description is updating anti-lock braking system or airbag system which requires strict validation, and the example is braking algorithm refinement. So these are the various examples or various ways in which OTA is already being implemented in the market. Now, how does this automotive OTA steps works step by step? Okay, first is update preparation, second is update distribution, and third is in-phase in-vehicle update process. This is very similar to very general OTA which I touched upon in the previous slide, but in the previous video. But here also I will touch upon in a more elaborate manner. So automotive OTA is more complex than smartphone updates due to safety, reliability, and regulatory concern. Okay, first when it comes to update preparation, software build and testing. Automakers develop updates in controlled environments and rigorous validation ensures no failures. Rigorous validation through hill and sill testing. First you have to ensure that the software is foolproof. Next is packaging and signing. Updates are encrypted and signed using HSM backed key. And coming to delta updates save bandwidth. Alright, so this update preparation includes delta updates and only changed code is sent. Now coming to the update distribution, the cloud-based OTA server automakers use platforms like AWS IoT, Airbiquity and Cibros. Updates are distributed via cellular, 4G, Wi-Fi or satellite. Next, coming to staged rollouts, updates first go to small test fleet and if successful, a wider rollout follows. Alright, now this is the part, these two, 1 and 2 are part of the update distribution. Now after the preparation is completed, distribution is completed, next comes the in-vehicle update process. Now again within update process has 4 steps. What is download phase, verification and pre-installation checks, next installation mechanism and post-installation verification. So going step by step, in the download phase, the telematics control unit downloads the update and it can be scheduled for low traffic hours. Always usually this OTA happens when the vehicle is at a standstill during low traffic hours, when there is more probability of the vehicle being standstill. Next comes the verification and pre-installation checks. It checks digital signatures like ECD, SA, RSA 2048 and it also validates battery level, ignition status must be parked. Third one is installation mechanism, which means dual bank AB partitioning and it update instills in secondary partition. If successful, the ECU boots from new partition and if it failed, it reverts to the old version. Alright, this reverting to the old version is a very famous or very popular failure. Okay, this type of failure happens quite frequently. And next is single bank with rollback. This is used for less critical ECUs. Example, infotainment. This is not exactly a very critical, of course it is important infotainment, but it is not important in the sense that failure will lead to fatality or anything like that. Okay, next coming to the post installation verification. The verification, the vehicle sends a confirmation report to OEM and it also diagnostics ensure no malfunctions. So after the verification or installation is completed, the vehicle gives a confirmation report. It is only after the OEM receives the confirmation report, then OEM considers its job done. Okay, so it is only, and that confirmation report, it is a certificate saying that diagnostics ensure no malfunctions. Now, who are all the major players in this OTA who are playing a very important role in this automotive OTA? First is the Tesla. Actually, this credit should go to Tesla for spearheading OTA in automotive industry. Okay, its role is to pioneer in the full vehicle OTA and its notable implementations are autopilot updates and battery optimizations. Next is Airbiquity, which is a OTA platform provider and used by Toyota, Ford and other automakers, but primarily Toyota and Ford are the famous examples. Next is the Harman, it provides OTA solutions, and BMW, Auto, Audi and Volvo integrations, or these are the famous OEMs which are relying on Harman. And when it comes to BlackBerry, it ensures that OTA is secured for ECU, and Jaguar Land Rover and Bosch depend on this BlackBerry QNX. Last is Cibros, and the role is deep connected vehicle OTA and EV startups and commercial vehicles. Now, security challenges and solutions in automotive OTA. As advantageous as this OTA is, there are certainly some major threats. First important threat, or the first major threat which is the primary concern, is malicious updates. Hackers inject malicious code into updates, and the solution is code signing, hardware security modules. Next is man in the middle attacks. intercepting, modifying updates in the transit, for example, doing the CAN routing or Ethernet routing. The solution is TLS 1.3 and also encrypted firmware packages. Next is rollback attack, forcing a vehicle to revert to vulnerable version. Next solution is version enforcement and secure boot. Fourth one is ECU exploitation via OTA. Okay, and what is the exploitation? It is nothing but compromising one ECU to another, attack another. For example, infotainment hacking CAN bus. So you compromise the infotainment so that you can hack the CAN bus. This is called compromising one ECU to attack another. And the solution is firewalling ECUs and ISO 21434 compliance. Now coming to the security standards of automotive OTA, ISO to SAE 21434, UNR 1555. Now in case you think this is a repetition of this of some of the topics which I touched upon in the automotive cyber security, please understand that automotive cyber security is extremely important when it comes to ADAS and also in the context of, in the perspective of OTA. AUTOSAR Secure OTA. It is standardized update framework. The regulatory and the compliance aspects, automotive OTA must comply with strict regulations. The most important regulation is UNR 156, which requires audit logs and cyber security checks. So whenever there is an update, that must be clearly logged so that it is useful for auditing. Next comes the GDPR, and OT must not leak driver data. And coming to NHTSA, safety critical update must not introduce risks. Okay, this is the regulation. NHTSA and FMVSS are the regulatory body concerning the USA region. And China CAC and MIIT, they mandate local data storage for ITA updates. Coming to the future trends in automotive OTA, AI powered predictive updates include vehicle self-diagnose and request patches before the issue arrives. Patch is nothing but it is a cyber security, it is a how to say, a small patch of shield which is requested by the ECU. Next is V2X enabled OTA, and the vehicle receive updates via vehicle to vehicle or vehicle to infrastructure. This is a very important future trend, and I am sure in every future trend, in all the modules, you are seeing this V2X. Okay, I am trying to impress upon you the importance of V2X in the various verticals, whether it is cyber security or whether it is a OTA or whether it is functional safety. In every vertical, this V2X is extremely important. Next comes the blockchain for the OTA integrity. All right, this immutable logs for update history to make sure, or you have a record or a register of tamper proof. Okay, you need to have a record which is totally devoid of tampering. It must be tamper proof record. Next comes the zonal architecture OTA, and next gens use cars use domain architectures. Fewer ECUs, simpler OTA. Now zonal architecture again is a huge topic where the architecture or the wiring harness or the wiring architecture of the ECU is being categorized based on the area or of the vehicle. Okay, I strongly recommend please go through the zonal architecture topic in Google, so that you will understand what is meant by zonal architecture. And once you understand the topic, you will understand why next gen cars use domain controllers and how OTA is being simplified with the help of zonal architecture. Next comes the edge computing for OTA and local servers at dealership reduce cloud dependency. Now, what are the various case studies? The most famous case study, of course, is Tesla, the first automaker to implement full vehicle OTA. This credit by far must go to Elon Musk. He is the one who introduced this OTA in automobile industry, and many automotive industries, they followed the suit. The most famous example is it increased Model 3 braking distance via OTA way back in 2018. It also added dog mode via software update. This dog mode is you can or you cannot call it a ADAS feature, but it is a feature where the dog inside the vehicle can remain safe. All right. So, and that particular feature has been added with the help of software update directly from satellite or directly from cloud to the vehicle without visiting the service center. Next is improved battery charging curves for longevity. So, coming to the Ford, the most famous example is Ford Power Up OTA. It updates Sync 4 infotainment and Blue Cruise ADAS. This Blue Cruise is a ADAS feature used by the Ford, like Highway Pilot in Tesla. And it also added Amazon Alexa integration wirelessly. So coming to the Volkswagen series VW ID series MEB platform, it uses VW operating system for the OTA updates, and it also plans 48-volt architecture updates via OTA. Now coming to the conclusion, automotive OTA, let's see these challenges in automotive OTA. Which are the main challenges? Challenges is the legacy ECU limitations, because gradual shift to auto solution is gradual shift to AutoSAR adaptive, because even now there are some old old school ECUs which are not using AutoSAR, and in such case of ECUs, OTAs is extremely difficult. And coming to mixed fleet complexity, the custom update strategies for different models, and delta cost and bandwidth, which include solution like delta updates and Wi-Fi prioritization, and regulatory hurdles, collaboration with agencies like NHTSA, includes European GDPR. So these are the regulatory hurdles. Next comes the conclusion. Automotive OTA is transforming the industry by enabling software defined vehicles, and Tesla proved its viability. Now traditional automakers are adopting it. However, security, safety, regulatory compliance and legal systems remain challenges. So OTA, as useful as it is, there are definitely some challenges like security, regulatory compliance and legacy systems. Okay, regulatory compliance means even today there are plenty of regulatory bodies which are not in harmony with one another. So preparing or manufacturing one car in one area of the world and importing it to the other area of the world, that remains a big challenge because of the regulatory compliance disharmony. And the future will also see AI driven updates, V2X integration and blockchain secured OTA, making cars smarter and safer than ever. Thank you.